Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the ninth question from the mid-year examination, which was written in the province of Gauteng in the year of 2024. Please do expect a total number of 10 videos since the question paper had 10 questions in total. And please guys, do take this seriously because I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please guys, do share the video to your peers so that they may have the same edge as you. And please do help us grow the channel by just subscribing. Okay, in the diagram below, the diameter BE of circle O is produced to D. First statement, we are told about a diameter. BE is a diameter. I know that a diameter will always subtend an angle of 90 degrees at the circumference. These angles are called angles in a semicircle. And then we are also told that DA is a tangent to the circle, and CT and BD are perpendicular. Since DA is a tangent, I know that A3 is equal to B1 according to Tan-Cot theorem, and also A1 is also equal to E1 according to the Tan-Cot theorem. Are you together? Okay, and then we are told that AC and BC cut the circle at E and F respectively. OF and FE are drawn. We are told about the center, guys. I know that it should ring a bell to me that angle O2 is 2 times the angle at the circumference. Angle O2 is 2 times the angle at the circumference. Okay, now let's answer these questions, guys. Let's erase this thing just to avoid confusion. Prove that ABCD is a cyclic quad. ABCD. There's ABCD. For you to show that, guys, something is a cyclic quad, you can either show that opposite angles are supplementary, or show that the interior angle is equal to the exterior opposite angle of that particular shape, or you can show that the angles in the same segment are equal. The angles that are subtended by the same line segment are equal. In this case, we are going to prove by using the latter option, that this angle is equal to that. Okay, I know that angle A2 is equal to 90 degrees. This is just an angle in a semicircle. Are you together? And also angle D2 is equal to 90 degrees. Why? Because CD and BD are perpendicular to one another. So this simply means that A2 is equal to D2 because both angles are just equal to 90. I can therefore conclude that ABCD is a cyclic quad. The reason behind, you can say that angles in the same segment, and do write those angles. We are talking about A2 being equal to D2. That's how you're supposed to show that that particular shape is a cyclic quad. Question number 2. Prove with reasons that BD bisects angle ABC. We are supposed to show that B1 and B2 are equal. Okay, how can we do that? B1 and B2 are equal. I know that angle A3 is equal to angle B1 according to Tan-Cot theorem. Are you together? But also, I also know that angle A3 is equal to B2. These are just angles in the same segment of cyclic quad A, B, C, D. Remember, we've proven that we have a cyclic quad there, right? So that simply means this angle will be equal to that will be equal to that angle. Excuse me about that, guys. These two angles will be equal because they are subtended by the same chord. So angle A3 is also equal to angle B2, right? So I can therefore conclude that angle B1 is equal to angle B2. Why? Because both angles are equal to angle A3. And therefore, BD bisects. Therefore, BD bisects angle ABC. Why? Because B1 and B2 are equal. Okay, and then the last question, I'm supposed to prove with reasons that EC is a tangent to the circle OEF. Where is EC here? EC is a tangent to the circle OEF. Okay, let me erase here just to create room for me to write. EC is a tangent to the circle. So basically, I'm told that there's an imaginary I'm supposed to show that there's a circle over there that moves like that, and EC is a tangent to that circle. If EC is a tangent, guys, to that circle, basically I'm supposed to show that angle E3 is equal to angle O1. Angle E3 is equal to angle O1. So how can I do that? Okay, E3 remember that, guys, I know that angle E3 is just equal to angle ABC. That's an exterior angle of cyclic quad. Exterior angle of cyclic quad ABFE. ABFE. As long as, guys, you can see that your circle touches all the vertices of your four-sided shape, that means you have a cyclic quad, né? And then E3 is the exterior angle of that cyclic quad. Are we together? So that means E3 I can say that E3 is 2 times angle B2. E3 is 2 times angle B2, right? Why? Because B1 and B2 are equal. This is angle ABC. So this entire angle is just 2 times this one angle over there. Okay, and what else do I know? I know that angle O1 is 2 times angle B2 as well. Angle at center is 2 times the angle at circumference. Are we together? So I now know that E3 is 2 times angle B2, as well as O1 is 2 times angle B2. Therefore, E3 is equal to O1 because both angles are just equal to 2 times angle B2. Therefore, EC is a tangent to the circle. Therefore, EC is a tangent to the circle. The reason behind, you'll simply say tan-chord theorem. Tan-chord theorem. Now I've shown that this guy over here is equal to that one. Are we together? So that will be true if and only if EC is a tangent. Remember that we were told that we must show that EC is a tangent to the circle that passes through E, F, and O. So if E3 is equal to O1, we can therefore conclude that EC is a tangent according to tan-chord theorem. That's how, guys, we're supposed to tackle this question over there. So please do stay tuned and wait for more videos. Thank you.